So welcome back to this video segment. We are in the middle of discussing the pillow library and we are moving on to a new set of commands. They're called new copy and paste. Actually, we have seen dot copy a little bit, but let's consider them. This is almost a bit like implementing a software, image processing software's menu functions, right? Like I want a new image, a new canvas to draw things. I want to copy this image, but parts of it, and then paste it here, something like that. So again, this is not about replicating what we can do manually. So that comparison is not correct. Huh? I can also do it myself, so that's not the point. The point is we can do it programmatically. I can run this new copy and paste 1,000 times, and you cannot. Right? All right, so let's see how we do it. And notice this is all the code we have. Very simple. Our goal, let's say, is to create a collage. All right, so normally we'll source from image 1, 2, and 3, but let's say we only have one image. And we will obtain different sub-images by cropping. Remember what's cropping? Cropping is select this subset of the pixels. Yeah, so we can crop from 100, 100 for 500 pixels wide. No, from 100, 100 to 500, 400. And therefore the size is 400 pixels by 300 pixels. 500 minus 100, 400 minus 100. Right, top left, bottom right. So we extract out this image and store it into image 2. So it's only this image. All right. Then we extract 3 more. A squarish kind of cropping from this little jar here. So the jar is 1200 by 600. So 1200 is probably here by 600. It's probably here. So it's over here. Okay. Then we can also extract the size 400 by 300 from 900 comma 0. 900 comma 0. So that's, sorry, 900 comma 0 is probably 900 comma 0 from here. All right, so that's where we end up getting this orange guy. So it's, where's my 900? Oh, 900 is over here. Okay, 900 comma 0. So we end up getting a bit of the orange guy over here. And finally, we get a squarish crop positioned at 300 comma 400. So we get the left arm of the guy in black t-shirt. So let's see, sorry again, and 300, 400 over here. All right, so we crop out this small little part. So we are doing this programmatically. We are not trying to do this manually. All right, so we now have 4 images, 2, 3, 4, 5, and our intention is to create a new canvas. We want that new canvas to have a background that is orange in color. So imagine buying this huge art paper, all right, that's very large, and it's all orange, and that's our canvas. So a canvas is just a new image. So image.new. So create a new blank image. If we don't specify color, it'll be black. So we specify a color. You can have it as white. Remember the hexadecimal code for white, FF. So here we have full intensity for red, FF, medium intensity, exactly half, 80 for green, and a little bit of blue, right? So this gives us the effect of orange. And we want it to be of size 700 by 600 wide. All right, so now we paste image 2 at the starting point. Image 2 is 400 by 300. So we're going to be left with, because the width is 700, we would expect the remainder here to be 300. Yeah, and it is 600 high, right, in terms of height. So that means halfway will be 300. So top to halfway will be 300. So it will look like a square. And indeed, it is a square. So we'll paste image 3, which is a square, right, onto this position. Where is this position? What we want is that we want the width of this square, which is 300, to minus off the width of the image, which is 200, and then we will have 100 pixel of red, orange, and we divide into half so that we have left-hand side a border and right-hand side a border, right? So we have 50, and 50 is to be added on to this point here. What is this point? This is 0 until 400, right? So 400 plus 50 will be here. So we will want this position to be 450, comma 50. Yeah. So this is exactly the reason why. Then, by the same calculation, we know that from left to right, we want 50, and from top to bottom, we want 300, because the height is 300, plus 50. So we will have 50, comma 350, and that gives us this squarish paste. And finally, the last image. Okay, that's 300 by 300. Okay, so notice that we are using the new image collage, right? Image collage is the new image. And then dot base means based onto this collage image, this new source image, image 2, at this position, this tuple. So basically the barest most information needed, and the function will do the right thing. Okay, so new, copy, and then paste. The copying is done by the cropping, because cropping means I copy from this section of the original source. The dot copy, on the other hand, is an exact replica of and complete replica of the original. Okay, since we are talking about pasting, right? Remember the dot paste? The pillow library is interesting. The dot paste has a documented use of um, changing the color of a single pixel. So the idea is that we use dot paste. All right, we can use dot paste to paint very quickly and efficiently a block of pixels of size x size, comma y size at the point x, comma y. So we can say dot paste color, comma x, comma y, comma x plus, so the top left, comma the bottom right. Yeah. So when we do this, and the entire rectangular block will be painted in some sense, not pasted, but painted with that color. And this doesn't have to be an image. It can be just a tuple or a hexadecimal string. So something like this. We new image a size of 300 pixels, 200 pixels of yellow color. All right, this is red and green that will give us yellow with a tint of blue. All right, that's all. Then we say we paste, right? We paste blue, the color blue, because color blue is well defined. Or you can specify a tuple 0, 0, 255, right? And starting at 150, comma 100. So 150 here, 100 down. This is the starting point. Ending point is plus 30 pixels, plus 20 pixels. So that's 180, 120. So we get a bluish rectangular block painted here very efficiently. So the dot paste is able to, utilize hardware if necessary to very efficiently paint it. Okay. The nice thing is it is also efficient when you reduce the size to 1 pixel. So you go x, comma y, comma x plus 1, comma y plus 1. So that will be painting 1 pixel at exactly x, comma y. So that's what we do here. We do a dot paste, red, full red, no green, no blue, comma, at the point 100, comma 50, 100, comma 50, this point here, and I enlarge it to show you here. All right. Until 101 and 51. So you need to have a plus 1 there, or else you don't see the dot. Okay, so when you, if I don't know if you can see this little red dot, but it definitely is one red dot over there when I try to enlarge the picture, right? So I see this. So this dot is basically the smallest version of a rectangle. You can also paint the whole screen, whole image of certain color. Okay, so here we try to paint a line. So we try to paint a line. How do we go by that? This line needs to be either horizontal or vertical. It cannot be slanted. So we want to paint a green color. And also I take the opportunity to show you a tuple specification of color. So 0, 0, 255 means full green, right? At the position 299. Now, why is it 299? Because the first pixel is 0. If my pixel count is 300 in width, usually we are not so strict about counting exactly. Yeah? Because if we say we want a 300 pixel width image, whether it's 299 or 300 wouldn't really change the picture a whole lot. But because we're trying to draw the border line 1 pixel wide, we need to count very carefully. The first pixel is 0, and for 300 pixel wide image, the last pixel must have the address 299. So starting at and including at 299 until and excluding 300, okay, paint the width, and then starting at 10, which is 10 pixel down from the top, and ending at 180, which is 20 pixels up from the bottom, paint the entire rectangular block green. So this turns out to be 1 pixel wide, which is a line. So you can do the same trick for a horizontal line. What about slanted lines? No. Okay, so this is for efficiency. We can deal with horizontal, vertical lines and blocks very efficiently. So paste is definitely optimized for that. For other geometrical figure and drawings and all that, we have to look further down using image draw. So stay with me to that segment of the video. But for now, suffice it to say, dot paste can also be used for pasting onto a pixel a specific color. Now, if you look at the Pillows documentation, you could find a put pixel function. So it's like image8 dot put pixel at the location a red tuple. It is also documented there that such a put pixel is inefficient. So if you care about putting one red dot, perhaps that's fine. Either way is fine. But if you want to put a lot of dots because you're simulating fireworks or whatnot, then documentation says it's not efficient to use dot put pixel. Rather, you should consider using dot paste. So this is what we try to do here. If we can paste a specified color to a pixel location, can we read back the color from a specified location? Answer is yes. You can use a dot get pixel, all right, dot get pixel. So from this image 8, I want to get the pixel color, all right, at the location 99, 50, which is 1 pixel to the left of our red pixel 100, 50, right? So when we print it out, it's full red, full green, little bit of blue. That's our yellow. It's not red. But if we get pixel at 100, 50, we see that it is full red, no green, no blue, which is the red dot. So yes, we can teach your Python program to look at that pixel and say what color it is. And that's the beginning of how we can ask our Python program to inspect the image pixel by pixel if you want. Yep, so that's the beginning of good stuff, right?